Welcome to our channel. In today's video, we'll explore the fascinating world of ocean thermal energy power plants. These innovative facilities harness the temperature difference between warm surface water and cold deep water to generate renewable energy. Stay tuned to learn how this sustainable solution is shaping the future of clean power. Don't forget to subscribe for more exciting content. Number 5. Harnessing the power of oceans. Ocean thermal energy conversion, OTEC, is a technology that utilizes the temperature difference between warm surface seawater and cold deep seawater to produce electricity. The basic principle behind OTEC is to exploit this temperature gradient to drive a heat engine. Warm water from the surface, typically around 25 degrees Celsius to 30 degrees Celsius, is used to heat a fluid with a low boiling point, such as ammonia. This vaporized fluid then drives a turbine connected to a generator to produce electricity. The cold, deep seawater, which is typically around 5 degrees Celsius to 10 degrees Celsius, is used to condense the vaporized fluid back into a liquid, enabling the cycle to repeat. OTEC offers a continuous, renewable energy source, unlike solar or wind power, as it relies on the stable temperature differences found in tropical ocean regions. The power generation process is environmentally friendly because it does not produce emissions or use fossil fuels. As the oceans cover approximately 70% of the Earth's surface, harnessing their thermal energy has the potential to significantly contribute to global energy needs, particularly in remote island communities or coastal areas. Number 4. Renewable energy source. Ocean thermal energy conversion, OTEC, is a renewable energy source because it relies on the natural and continuous temperature differences in ocean water to generate power. Unlike fossil fuels, which are finite and release harmful greenhouse gases when burned, the OTEC systems do not produce carbon emissions or other pollutants. The process is inherently sustainable because the ocean's temperature difference is a constant and natural phenomenon, not subject to fluctuations like weather patterns or seasonal changes. This makes OTEC a highly reliable and stable energy source, which can operate 24/7, in contrast to other renewable sources like solar and wind power, which depend on weather conditions. Additionally, OTEC systems do not require large land areas or disrupt local ecosystems, making them an attractive alternative to land-based power generation. As global energy demand continues to rise, the need for sustainable, clean, and reliable energy sources is more pressing than ever. OTEC, with its ability to generate large amounts of electricity in a non-polluting manner, offers a promising solution to help meet these demands while mitigating the negative environmental impacts of conventional power generation. Number 3. Ideal for tropical regions. OTEC systems are most effective in tropical and subtropical regions, where the temperature difference between surface water and deep water is significant. These areas are typically located between latitudes 23.5 degrees north and 23.5 degrees south, where the ocean's surface temperature is consistently warm, while the deeper waters are cold due to their greater depth. In these regions, the temperature gradient is large enough to create the necessary conditions for OTEC systems to function efficiently. The temperature difference typically ranges from 20 degrees Celsius to 25 degrees Celsius, which is sufficient to drive the heat engines used in OTEC technology. As a result, tropical islands and coastal areas, especially those far from grid-connected power sources, are well suited for the implementation of OTEC systems. These regions can benefit from clean, renewable power generation without relying on imported fuels, which are often expensive and difficult to transport. Moreover, tropical areas often experience high energy demands due to tourism and growing populations, making OTEC a particularly viable option. Additionally, these regions benefit from abundant water resources and the lack of significant seasonal fluctuations in ocean temperatures, ensuring consistent and reliable energy production. Number 2. Diverse applications. In addition to electricity generation, ocean thermal energy conversion, OTEC, offers a range of potential applications that make it an even more attractive technology for various industries. One of the most notable applications is desalination, where OTEC systems can produce fresh water from seawater. The cold, deep seawater extracted by OTEC systems can be used in reverse osmosis processes to desalinate water, providing a reliable source of drinking water for coastal areas and islands with limited freshwater resources. Furthermore, OTEC can support aquaculture by providing a consistent supply of cold, nutrient-rich deep seawater that can improve the growth rates of fish and other marine species. The waste heat from OTEC systems can also be used for cooling purposes, particularly in air conditioning systems. By utilizing the natural temperature differential between deep and surface waters, OTEC systems can provide cost-effective cooling solutions in tropical and subtropical regions. These diverse applications not only enhance the economic feasibility of OTEC, but also help address pressing challenges such as freshwater scarcity, food production, and energy demand in coastal and island communities around the world. Number 1. Technological challenges. Despite its potential, ocean thermal energy conversion, OTEC, faces several technological challenges that hinder its widespread adoption. One of the main obstacles is the high cost of building and maintaining OTEC plants, especially in remote offshore locations. The installation of underwater pipelines and heat exchangers capable of withstanding the harsh marine environment is expensive and requires advanced engineering. Additionally, the efficiency of OTEC systems remains a challenge. While they can produce continuous power, the energy conversion process is relatively low in efficiency compared to other power generation technologies. The size and scale of OTEC systems required to make them economically viable further complicate the implementation process. There is also the challenge of transporting the electricity generated to land, as OTEC systems are often situated far offshore. Furthermore, while OTEC plants are reliable, they still require significant upfront investments, which can deter investors and governments from pursuing such projects. Research into improving efficiency, reducing costs, and scaling OTEC systems is essential for overcoming these barriers and unlocking the technology's full potential as a global energy solution. Thank you for watching. We hope you found this video on ocean thermal energy power plants insightful. If you enjoyed it, please hit the subscribe button for more updates on sustainable energy technologies. Stay tuned for our next video.